We tend to think genius means answering impossibly hard questions. But the people who changed science were often the ones fixated on questions so simple that everyone around them had stopped asking. 5 habits keep turning up, and not one of them is raw intelligence. Number 1. They kept asking childish questions. When Einstein was 16, he wondered what it would be like to chase a beam of light and catch up with it. What would the light look like, frozen, hanging there beside you? It's the kind of daydream a child might be told to put away. Einstein never did. A decade later, that question, pursued with absolute seriousness, helped lead him to special relativity. Galileo did much the same nearly 3 centuries earlier. Everyone knew that heavier objects fell faster than lighter ones. Aristotle had said so, and that settled it. Galileo asked the childlike follow-up, but what if you tied a heavy stone to a light one? The lighter stone should hold the heavier one back. Yet together they weigh more than the heavy stone alone, so the pair should fall faster. Both cannot be true. By exposing that contradiction, Galileo showed that weight alone could not determine the rate of freefall. Whether he ever performed the famous Leaning Tower demonstration remains uncertain. The argument itself was real, and it was devastating. Number 2. They could sit inside a contradiction without flinching. Most of us, when 2 facts won't fit together, rush to throw one of them out. Great scientists learn to hold the discomfort. In 1900, Max Planck found that he could explain the glow of a hot object only by treating energy exchange as if it occurred in tiny, discrete units. An assumption that sat uneasily with the physics of his day. He later called the move an act of desperation and spent years trying to reconcile it with classical physics. Einstein confronted 2 principles that seemed impossible to square. The speed of light is the same for every observer moving steadily, and no observer in steady motion is special. Rather than abandon either, he let go of something more deeply rooted, the idea that time is the same for everyone. Number 3. They thought in pictures long before they thought in symbols. Michael Faraday received only a basic education and was apprenticed to a bookbinder as a teenager. He had little training in the advanced mathematics of his day, and yet he could picture what others could not. Invisible lines of force threading out from a magnet and filling the space around it. He did not express the idea in equations. He saw the picture first. Years later, James Clerk Maxwell built a mathematical theory from Faraday's pictures, equations that still describe the electromagnetism behind motors, radios, and much of modern technology. The picture came first, the mathematics came after. That sequence, vision first, equations second, repeated throughout science. The chemist Auguste Kekulé later said that the ring structure of benzene came to him in a daydream of a snake seizing its own tail. Whether the story is literally true remains debated, but the broader lesson holds. A breakthrough can arrive first as an image, with rigorous work following to test what intuition has suggested. Number 4. They were willing to kill their own beautiful ideas. Johannes Kepler spent years trying to fit the orbit of Mars to a perfect circle, a shape long regarded as divinely perfect. He came close. His circular model missed the observations by roughly 8 arc minutes, an angle far smaller than the width of a coin held at arm's length. He had every excuse to ignore it. Instead, he trusted Tycho Brahe's measurements, discarded the circle he loved, and eventually discovered that Mars moves in an ellipse. He later wrote that those 8 tiny minutes would point the way towards reforming the whole of astronomy. Even Einstein did it, though reluctantly. When he applied general relativity to the universe, his equations did not naturally produce the static cosmos he expected. So he added a cosmological constant to hold the model still. Later, theoretical work and observations by Georges Lemaitre, Edwin Hubble and others made an expanding universe increasingly compelling. Einstein abandoned the static model and reportedly called the introduction of the constant his greatest blunder, though the exact wording remains debated. The willingness to kill a theory you adore is far rarer than the talent to build one. Number 5. They didn't wait for permission. In 1905, the man who would rewrite physics was not a professor. Unable to secure an academic post, Einstein worked as a patent examiner in Bern, assessing other people's inventions by day and developing his own ideas in his spare hours. The academic world had not yet made room for him. He kept going anyway. Charles Darwin held no university chair either. A gentleman naturalist working outside a university, he spent roughly 20 years developing natural selection, amassing evidence and pursuing other major research. Then, in 1858, a letter arrived from the other side of the world. A younger naturalist named Alfred Russel Wallace working independently in the Malay archipelago, had reached a remarkably similar idea. The letter did not create Darwin's theory, but it changed the timetable, prompting a joint presentation of their work and accelerating his completion of On the Origin of Species. The patience to keep working without a formal post, and the obsession to stay with a question for decades. You find these qualities in scientist after scientist, century after century. So there they are, the childish question, the patience to sit inside a contradiction, the picture before the mathematics, the courage to kill a beautiful idea, and the will to keep going without permission. 5 habits, and not one of them is what we usually call intelligence.